So, welcome to the second part of this morphometric indices series. In first part, we learned the basic theory of what is SL index and what are the parameters required for its calculation. Along with that, we also learned its purpose and its applications. So, to calculate SL index, we need a vector file of river or stream and a raster file of digital elevation model for our area of interest. Okay, so this is my QGIS interface where we are going to load both of them. So first, before we start working on QGIS, so it should be our tendency to save our project because it provides easy access to all the required files in our project. So first, let's begin by saving our project. So to save your project, go to Save Project here, or you can also go to Project and then Save. Find a folder in which you want to save your project. Morphometric analysis. Okay, click on Save. Okay, so what will happen after saving our project? In your browser panel, you will get a project home. So in this project home, when you will expand it, you will find all the files that you will require for your analysis. So first, let's load a stream that we are going to use for our analysis. So if you don't know how to get this browser and layers panel, please check out our previous videos and I'll provide the description. I provide the link in the description box from where you can directly access to those videos and you can learn the basics of all these things in QGIS and then further proceed for this video. Okay, if you want to get any panels and toolbars in QGIS, just right click on this gray band here or the menu bar. Okay, and here you will get all these toolbars and panels. Okay, so let's load our river. This I have given you in the Google Drive link that you will find in the description box again. And we will load this by just dragging and dropping it to our interface. Okay, so this is our river. This is the river that we are going to analyze for our work. Okay, so let's go to layers panel and check that our layer is loaded. Okay, so if you go to the properties here, you will find that the units are in geographic. Okay, latitude longitudes are in geographic coordinate system. However, we need the measurements in meters, so we have to reproject this layer to the projected coordinate system. Okay, so this area falls in 43 north UTM zone, so we are going to reproject this layer into the required projected coordinate system. So for that, go to vector, go to data management tools and find this reproject layer option. Okay, so in input layer, you have to select the layer which you want to reproject. Your target CRS you have to define 43 north. If you do not have this particular list in your interface, then you can go by clicking on this small icon, change it to predefined CRS and here find 43 north. Okay, you will get it here, or in the projected coordinate system under UTM, you will find this UTM 43 north. Okay, and this will also highlight whether like what is the area in which this zone falls. Okay, then go back. We are not going to change any other settings here. We are just going to save our reprojected layer. Okay, click on save to file. Okay, and just say reprojected. Okay, click on save and then run. Okay, so when the algorithm says the reprojected layer finished or a particular result is finished, then close it. Okay, so now we require this reprojected Godavari river layer. Okay, so next we want to divide this particular area, this particular river into number of grids. Okay, because that number of grids will define the reach for us. Okay, so the reach we were talking about, that will define the reach for us. For example, this point A and this point B. Okay, so let's come here. So we saw this diagram. So this is the reach, right? A point and B point. So we have to divide this river into different reaches. Okay, so that's what we are going to do here. So let's create a grid for it. So for that, go to processing, processing toolbox, and here you have to find create grid. Okay, create grid here. Double click on it, change grid type to rectangle and polygon, define the grid extents. Okay, define the grid extent using the reprojected or any sort of any layer from here. And horizontal spacing, let's give it 1 kilometers. Okay, so it will be 1000 meters and 1000 meters. Okay, so right now it is in degrees, but if we will change the grid CRS to 43 north, then it will change into meters. Okay, so after changing here grid CRS, make sure you again check that this has whether it has converted into meters or not. Okay, and also if you are interested in using other units than meters, then you can change it from here. Okay, then after that we will save this file as river grid. You can name it whatever way you like. Okay, click on run, close it, and this is the grid that we have got. Okay, so this is the grid that we have got here. And let's move this to bottom here and check where our river is falling. Okay, you see this is the grid that we have. Okay, now yeah, let me change first the color of this river. Okay, so click on the layer for which you want to change the style and click on this open the layer styling panel here, and you will see that there are options to change the color. Okay, so this is what we can do here. So also you can measure whether this grid is of correct size or not. Okay, this you will find in attributes toolbar. Okay, so you know how to get the toolbar and panels. So click on this measure line option here. Okay, and check the size of the grid. See, it is approximately 1000 meters. Okay, so we will close it. Okay, so you see our river is divided into number of grids, but there are so much of so many grids that are empty in which our river is not included. So we just want the grids in which our river is intersecting, right? So for that, what we will do, so for that, what we are going to do, we are going to just clip out. Okay, our final result will be the grids that only include this particular river network. Okay, so for that we are going to use 2-3 processing. So first is we are going to join. Okay, we are going to join the reprojected Godavari river with our river grid. Okay, and that will be based on their location, and such joins are called spatial join. Okay, so we want to join features in river grid because we want the result to be as grids. Okay, and by comparing it to our reprojected river. Okay, and the join type will be 1-to-1. If there is any particular field which you want to extract from your second layer, then you can go here and select them. Okay, how, and we are going to discard records which could not be joined. Okay, and let's save our results. save to file as joined grid and river. Okay, click on run. Okay, so it is finished. Close it. So you see we have got the grids which just intersect with our river, and we do not require this river grid. Okay, we will close it, and if you will zoom in, then you will see the grids. Let's move it to the top so that we can see our final result. So now if you will notice that this river, the reprojected Godavari river clip, if I select this, so how you will get this selection toolbar. So this is called selection toolbar, and that you can get by right clicking and going into this toolbars. Okay, so here you will find selection toolbar. So in this selection toolbar, choose the select features by area or single click. Okay, to select any vector file, any vectors in your workspace. So if I select this, so you will see that this river is broken, right? So this river is broken into different segments, and this is what we do not want. And here you see there are two different parts of this in this particular section. Okay, so we do not want such data for our analysis. We want a continuous river. Okay, and then we are going to split that river into segments, but to define our reach within this grid. Okay, so let's first delete this particular such spurious data so that our final results are correct. Okay, so for that, highlight this and click on this toggle editing button. Okay, and then click on this delete button so that your extra or whatever data you do not require gets deleted. Okay, and after that, make sure to save your edits. Okay, and you can also check whether other parts of this river have the same problem or not. Okay, but we have first, our task will be to make it a continuous river. Okay, so for that we are going to use the dissolve geoprocessing, okay, or vector processing, so that we get a continuous river. Okay, so I'll save this as continuous river. Okay, click on save and then run. Close it. And now if you will notice, if you will highlight this river, continuous river, and select this, you will see this is now a single river. Okay, so now our river is ready to get segmented into different parts. Okay, into different parts, let's say, or our river is ready to get segmented in the different reaches that is defined by this grid. Okay, so to split our river in our desired way, we are going to use the intersection. Okay, intersection of vectors. Vector, then go to geoprocessing tools and find this intersection. Okay, so our input layer will be continuous river, and our overlay will be our river grid. Okay, sorry, that will be our joint grid and river. Okay, so we want to intersect our river based on our joint grid and river. Okay, and save to file as intersection river. Okay, or intersected river, whatever name you want to keep. Click on run, click on close, and if you select this intersection river in the layers panel and then use the select features by area or single click, you will find that our river is now segmented, okay, according to this grid, according to our reach. But here the problem is, you will notice that you see in this particular part of river, it again is entering into this particular grid. Okay, so this is a kind of multi-part geometry, and we do not want multi-part geometry here. Okay, so now we have to convert this multi-part geometry into single parts so that we can count these two as different segments, but in a same grid. In the right now, these are the same, these are defined as the same segment, okay, but we want it to be created as different segments. So for that, you will go to processing toolbox here, okay, and find multi-parts to single parts, okay, multi-part to single parts. So we want intersection river, okay, to single parts. So we will save this as our final river, okay, or you can say the final reach, okay, final reach, because this we are going to use to calculate the length of the reach. Click on run, okay, close it. Now your final reach, in your final reach you will see that now these two are different parts, okay, and even these two are different parts, right? So I think we are now in the stage to calculate our first parameter, okay, which is our delta L, which is the point between A and B, which is the distance between point A and point B. So now we are in the stage of calculating our first parameter, that is delta L, okay. So right click on it, open its attribute table, okay, and we will calculate the length using a field calculator, okay. Open the field calculator. Here you give it a name, or let's say length of reach, okay. So it has some limitations of character. I'll just write length of reach, okay, like this, and let's keep it decimal. So for that you will just do and GTH, okay, length. You see, in preview you will get this particular number, okay. Click on OK. So here the length is calculated, okay. So if you want to make sure whether the length is correct or not, first dock this attribute table, okay, and select the particular reach, okay, and this gets selected, and this is the length. And if you want to cross verify, you can use this measure tool, measure line here, and just make a rough uh, clicks over the river and check whether the calculations are correct or not. So this is approximately 1100, okay. So the calculations are correct, and let's de-highlight it. But here the one problem is still there, which we have to correct manually. So the problem here is that these IDs, okay, this ID column, this is randomly organized, okay, and but we need the river or the grids to have a continuous ID which starts from here. Let's say it starts with 1 and it's 2, 3, 4, 5 like this, so that it makes our calculation easier. But here if you will notice, if I highlight this 12, you see the 12 is here and 147 is here, and this is your 275, which should be here, right, which should be here, but it is somewhere here, okay. So this we have to organize first before going into further calculations. So I'm going to demonstrate one or two here, one or let's say 10 IDs, how you can how you have to correct it, and then we will move to the next part, and then we will calculate our difference in height, okay, or delta H, okay. So let's first calculate its new IDs. Again we are going to add a new field, okay, which will be called as new underscore ID. That will be our integer. Click on OK, and a new field is created, okay. So we will give it ID continuously, okay, from where our river starts. So we will give it a ID, okay. So this will be called as 1, right, and then this will be called as 2, and this is 3, this is okay. So we cannot see where it is, so we will just click on move selection to the top, okay. Here it will be 4, and this will be 5, this should be 6, this should be 7. Okay, and then this should be 8. This should be 9. Okay, and this should be 10. Okay, so in the same way you have to correct these IDs for all the 939 or whatever the data you have. You have to correct it for that particular data. Okay, then only you can get your further results correctly. Okay, so I'm going to stop this part second here, and in third part we are going to learn how to calculate the delta H. Okay, and then we will proceed for further calculations. So let's move on to the part 3.